Good morning, part two. We are in Pythagorean theorem part two page. Hopefully you got enough done on that first one. If you had any questions, make sure you had asked them. As we go through this, pause the video and work through some of the problems on your own. And as you have any questions, write them down, ask questions, or submit them to me on Schoology. We are going to continue practicing the Pythagorean theorem. Remember, the Pythagorean theorem says that a squared plus b squared equals c squared. And we need to figure out our missing side lengths. So let's check this one here. We know we got two legs on this problem here, 2 and 10, and our missing side length is our hypotenuse. And remember, the hypotenuse is directly across from that right angle. It's always the longest side, so we know that our answer has to be greater than 10. So let's check this out. Let's start out by starting with leg 1, 2 squared, plus leg 2, 10 squared. And we want to know we know that that equals our c squared, which is x. And we are going to split our equation so that we can solve. Let's simplify. 2 squared is 4, 10 squared is 100, and that should equal x squared. Let's simplify a little bit here. We know 4 plus 100 is 104, still equals x squared. Let's finish this up here. 104 equals x squared. Now to solve this, we need to simplify by getting the x by itself. And we know to do that, if we have an x squared, we need to take the square root of both sides, because squaring and square roots are opposite operations, inverse operations here. Well, the square root of 104 is not a perfect square. So we're not even going to do anything to that. We're just going to leave it exactly how it is. And we're going to say that our answer is x, because the square root of x squared is just x, is the same as the square root of 104. So x here is going to equal the square root of 104. Okay. Pause the video now and see if you can work through question number 2, which has the side lengths of 4, 9, and x, and notice the side length that is missing. Okay. Pause this video and see what is there. Now that you are back, let us finish this problem here. Let's see how you did. Okay, we have a side length 4, which is part of the right angle. So that's a leg. The other part of the right angle is this side here, which is our unknown. That is an x. And the third side length is the hypotenuse, which is 9. So as we solve these, we're not going to use, well, we're still going to use a squared plus b squared equals c squared. However, instead of having a and b, we have a and c. So let's plug those in. We said a is 4. We don't know what b is. It's an x. And we know that that's going to equal our c squared, which is 9. And now let's go through and solve this equation. This is 16 plus x squared, and that equals 81. We need to get the x squared by itself before we can take a square root. So let's subtract 16 from both sides. When we do that, we get x squared equals 81 minus 16, which is 65. And now our last step to get the x by itself is to get rid of that square, so we take a square root. And again, 65, not a perfect square. If it was 64, it would be a perfect square, but it's not. So x is going to equal the square root of 65. And you're all done. Let's check another problem here. Which lengths form a right triangle? This was that converse to the Pythagorean theorem, which we did yesterday in class, or if you're watching this at another time, we did it in class in lesson 1. This is lesson 2. We need to figure out which one of these, or if any of them, are a right triangle. To know that, we got to do the converse to the Pythagorean theorem, which says if a squared plus b squared equals c squared, then right triangle. If a squared equals c squared, then right triangle. So let's just pick one of these, and then I will have you do the other two on your own. Okay, let's pick this one here, this nice easy one. Remember that C is always the biggest value. 8, 15, 17, biggest one is C17. So let's try the other ones. 8 squared plus 15 squared, a squared plus b squared. We want to know, does that equal 17 squared? Okay, let's solve it. I'm going to simplify. It's not a very straight line, is it? Let's try that again. Better. 8 squared is 64. 15 squared is 225? I believe so. 225 plus 64 is 289. 17 squared is also 289. And we have the same number on both sides, which proves it, yes, it is a right triangle. Okay, you can try these other two. Pause the video, work through those two, and see what you get. All right, welcome back. Hopefully you paused through that and you saw those answers. Okay, let's check it out. 5 square root of 8, 33. The square root of 8 and 5 are smaller than 33, so we're going to say 33 squared should be, if it is a right triangle, the same as 5 squared plus the square root of 8 squared. And we want to figure that out. Does that equal 33 squared? As we simplify, that's 25 plus the square root of 8 squared is just 8. And 33 squared is a really big number. And I don't think that's going to work out in any such way. 25 plus 8 is 33. That definitely does not equal 1089. So what do we say? We say no. We said yes here. And let's check our last one. We have the square root of 2, the square root of 2, and 2. Well, which one's the longest? Well, 2 is going to be the longest one. So what are we going to do? We're going to take the square root of 2. We're going to square it. We're going to add to that the square root of 2. We're going to square it. And we're going to want to know, does that equal 2 squared? Let's find out. Well, the square root of 2 squared is just 2. The square root of 2 squared is just 2. And 2 squared is 4. What's 2 plus 2? Well, 2 plus 2 is 4. Does 4 equal 4? Yes, it does. Right? And we are done with page 2 of our notes.